Hello and welcome to this clip looking at the impact of experimental errors on enthalpy calculations. We're going to explore it using a multiple choice question. So here's our question. It says a student carried out an experiment to measure the enthalpy change of the combustion of methanol. And the energy was used to heat a beaker containing water. And the student's calculated enthalpy change of combustion was more exothermic than the value in data books. So what does this mean? Well, basically, exothermic reactions carry a negative delta H value. So this, mathematically, means that the value calculated is more negative than expected. So what we need to do is think about the sequence of calculations required to work out delta CH. Firstly, Q equals MC delta T. Secondly, moles of fuel used is the mass that was burnt over the molar mass of the fuel. And finally, in this case, delta CH is minus Q over the number of moles of methanol. And in each case, you've got to consider, is there anything there that mistakes A, B, C, and D might directly affect? So let's think about moles equals mass over molar mass for the first mistake. So methanol had evaporated from the wick before the final weighing. When you measure the mass of the burner after the weighing, what that means is any loss in methanol, whether it's from burning or whether it's from evaporating, goes into the mass that you measure. So that means that the student thinks the amount measured as burnt is going to be bigger. So that means the moles appears to be bigger. In the second mistake, the calculation, that includes ethanol instead of methanol. Ethanol is a bigger molecule, so it makes the moles appear smaller as you're dividing by a bigger number. If there was incomplete combustion, not all the measured mass actually burns. So that means that delta T is smaller. And finally, the water boiled for 5 minutes before the final temperature is taken. So what's going on here is during boiling, more moles of methanol is used up, so the number of moles is artificially high again. So in the first mistake, if the moles are bigger, then delta CH will end up as a smaller number, which is less negative. In mistake B, if the moles are smaller, then delta CH will end up as a bigger number, more negative. In mistake C, if delta T is smaller, Q will be smaller, so delta minus Q over moles will be a smaller number, again making it less negative. And finally, if the number of moles measured is too high, it has the same effect as for mistake A. In other words, the value is less negative. So because they want us to work out which is more negative, in other words, more exothermic, we want to use B as our answer. Okay, hopefully this has helped you to have a think through this type of question. Thanks for listening. Until next time, see you soon.